The question is, evaluate the value of the integral of this function with respect to x. The function is 6x plus 7 upon square root of x minus 5 into x minus 4. Now to solve this question, first of all we take the given integral and we see that this integral is in the form of a linear upon quadratic expression of x. In the numerator, linear expression, and in the denominator we have been given a quadratic expression. Okay, so first thing what has to be done is to multiply the term given in the square root sign, that is x minus 5 into x minus 4. Okay, so it is a product of two linear factors and this is going to give me a quadratic expression. So taking x minus 5 into x minus 4, I'm going to get x square minus 5x minus 4x plus 20, or x square minus 9x plus 20. This value goes in the place of x minus 5 into x minus 4 to give me the integral like this. Okay, everything same, but in square root I get x square minus 9x plus 20. Okay, the integral in the form of a linear upon quadratic is solved by a special method, and the method is this, that in this first of all we write the numerator as numerator. Suppose the linear numerator is written as lambda times d upon dx of the term given in the square root sign, that is ax squared plus bx plus c plus mu. Okay, so in this question the px plus q is 6x plus 7 is written as lambda times the differentiation of x squared minus 9x plus 20 plus mu. This on differentiation would give me 2x minus 9, so 6x plus 7 is equal to lambda times 2x minus 9 plus mu. I mark this as equation number 1. On comparing the coefficient of x, look here that in this expression, in equation number 1, the term having x on the left hand side is 6x. So the coefficient of x on the left hand side is 6 and on the right hand side is 2 lambda, because on right hand side the term containing x is only 2 lambda x. So I get 6 is equal to 2 lambda, or it's quite obvious, lambda is equal to 3. And similarly 7 is equal to minus 9 lambda plus mu. Right? On substituting the value of lambda in this equation, I'm going to get 7 is equal to minus 9 into 3 plus mu. 9 3s are 27. 27 goes here. 27 plus 7. So I get mu is equal to 34. Okay. So on substituting this value of lambda and mu in equation number 1, in this equation I'm going to get 6x plus 7 is equal to 3 times 2x minus 9 plus 34. Okay, in next step what I'm going to do, I'm going to substitute this value in the place of 6x plus 7. Okay, so taking the value of 6x plus 7 and substituting in place of 6x plus 7, I'm going to get the integral like this. Now I'm going to divide the term in the numerator separately by square root of x squared minus 9x plus 20. So I'm going to get these two separate integrals. Okay, I assume one as equal to I1, the other one as equal to I2. The idea here by assuming them as I1 and I2 is that we have to solve them separately. Why? Because this is going to be done by substitution method. This is going to be done again by a method in which substitution is involved, and two different substitutions are to be done in both the integrals. So I've assumed that this is equal to I1 and I2, right? So taking I1, so the integration of I1 is quite easy because the differential coefficient of x squared minus 9x plus 20 is equal to 2x minus 9. Therefore, on substituting x squared minus 9x plus 20 is equal to t, I get d upon dx that is on differentiating both sides with respect to x, I'm going to get minus 2x minus 9 dx as equal to dt. I'm going to substitute 2x minus 9 dx as dt and x square minus 9x plus 20 as equal to t. So I'm going to get 3 times integration of dt upon root t, or 3 times integration of t to the power of minus 1 by 2. Okay, applying the formula of integration of x to the power of n, I'm going to get this as 3 times t to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This on solving gives me t to the power of 1 by 2 upon 1 by 2. So this will be equal to 3 times t to the power of 1 by 2 upon 1 by 2. This 1 by 2 is going to become reciprocal. So this is going to add 2 by 1 and is going to multiply by 3 to give me 6. So I1 is equal to 6 times root t, and in place of t I'm going to substitute x square minus 9x plus 20 to get the final value of I1. So this is the value of I1. Similarly, taking I2 is equal to 34 upon square root of x square minus 9x plus 20. The idea to solve this integral is that we have to write the value given in the square root, that is x square minus 9x plus 20. We shall write the quadratic term in the denominator as difference or the sum of the square of a variable term and the square of a constant term, as we have been doing in the previous problems. This has been done many times. Taking x square minus 9x plus 20. First of all, I see that the coefficient of x square is 1. So next step, what has to be done? I'm going to take the coefficient of x, that is minus 9. Ignore its sign, so it is 9 divided by 2, so I'm going to get 9 upon 2. Add the square of 9 by 2, subtract the square of 9 by 2 to the given expression. So I'm going to get the expression like this. The first 3 terms are going to become x minus 9 by 2 whole square. Okay, and we have to simplify these 2 terms. So this will be equal to x minus 9 by 2 whole square. This on squaring gives me 81 upon 4. On simplifying this, it is very easy to solve. I'm going to get this as minus 1 by 4. 4 into 20 is 80, so it's quite simple. So this gives me x minus 9 by 2 whole square minus 1 by 4. This 1 by 4 can be written as 1 by 2 whole square. So I'm going to place, instead of x square minus 9x plus 20, this value. So I2 is equal to 34 upon square root of x minus 9 by 2 whole square minus 1 by 2 whole square. Okay. Now to solve further, what has to be done? I have to substitute x square minus 9 by 2 as equal to t. Okay. So differentiating both sides with respect to x, I get dx is equal to dt. So here I'm going to place t. Here instead of dx I'm going to write dt. So I'm going to obtain 34 upon square root of t square minus 1 by 2 whole square. I know that integration of 1 upon x square minus a square, that is square root of 1 upon x square minus a square, is equal to log of x plus square root of x square minus a square. So applying the same formula here, I'm going to get this as 34 times log of t plus square root of t square minus 1 by 2 whole square. Replacing the value of t, I'm going to get this as 34 times log of x minus 9 by 2 plus square root of x minus 9 by 2 whole square minus 1 by 2. This value was equivalent to x square minus 9x plus 20. So I'm going to write it again to get the value of I2 as this expression. Okay, taking the value of I1 and I2, we have started the integration of this function. We have multiplied the term x minus 5 into x minus 4 to obtain x square minus 9x plus 20. We had written as equal to I1 and I2. And on placing the value of I1 and I2, which we have already solved, we get the value of integral as of the function which we were given as equal to 6 times square root of x square minus 9x plus 20 plus 34 times log of x minus 9 by 2 plus square root of x square plus 9x plus 20 plus the integral constant c. So this is how we are going to solve this problem. This problem was quite lengthy, okay, but it has to be solved anyway, and this is how we are going to solve this question. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.